So lately students have been having a lot of difficulty with ions, and they're like, what is ion? What are ions? What is ionic bonding? What are binary ionic compounds? How do I draw an ionic formula? And so I really wanted to make this video to clear up a lot of confusion that's in the air. So let's get into it. So ions, you can break them up into two. You can have cations or you can have anions. So cations are positively charged ions. They lose electrons. So if you think about it, because I know that can be like contrary, like, wait, what? So think about this. Let's say that something is stressing you out, okay? So let's say that you haven't paid your bills, right? And that's giving you a lot of stress. But let's say then you lose those bills and you don't have to pay them anymore and they leave, right? So you become happy because you're losing the negativity that's in your life. You become happy. So think about it this way. The electrons are negative. So they're bringing down that person, right? But when they're gone and you lose them, you become happy. You become positive, right? Now, anions, on the other hand, they have so much negativity that having, like, if they gain more electrons, actually it's going to make them happy. For example, in the case of chlorine, if you go, it has 7 valence electrons. So it really needs that extra negativity to have the octet. So again, an anion is going to be a negatively charged ion because it's gaining that electron. So when it gains something negative, it becomes negative, right? So again, if that doesn't make 100% sense right now, it's okay. I'm going to clear it up even more. So if you think about it, so a metal and a non-metal is going to give you an ionic bond. So for example, NaCl. If you go to the periodic table, Na is going to be in group 1. So again, Na, to have the octet, it really, if it loses that one electron that it has, it's going to be happy. Chlorine, like I said before, it really needs that electron to reach the octet to be happy. So again, Na, it readily gives up that electron. So it becomes positive because it's losing that electron, losing that negativity. Chlorine, on the other hand, it becomes negative because, again, it's gaining that electron. So usually what you see is you get a metal and a non-metal, and that's what makes an ionic bond. Technically speaking, there are values that you can see. So if you have less than 5, that's non-polar covalent. If you have between 0.5 and I think it's 1.4, then that's going to be polar covalent. And then if you have more than 1.5, that's going to be ionic. But in this case, what I want to say is that generally speaking, if you have a metal and a non-metal, like Na is going to be a metal, Cl is going to be a non-metal, then you're going to have ionic bond because the difference is great. Now, how does this go back to the cations? So Na, again, it lost that electron, so it's a cation. Okay, chlorine, on the other hand, gained that electron, so it's going to be an anion, okay? And the cation with the anion is going to have an ionic bond that's formed between the sodium and the chlorine, okay? Again, cations, they are positively charged because they're losing electrons. They're losing that negativity. They're losing what's bringing them down. Anions are gaining that negativity, and again, that's why you're getting a negative placed on it because, again, it's gaining that negativity. Now, how do you draw ionic formulas? Well, I'm giving you these examples. So let's go over it. So you have aluminum 3+, and oxygen is 2-. Oops, sorry. Well, you just have to trust me, oxygen is 2-. And so, again, I'll show you the other ones. Lithium is going to be 1. Technically it has a 1 there. We don't usually write the ones in chemistry, but it has a 1 there. It's going to be plus. S 2-, barium 2+, chlorine, again, you don't really usually write the 1s. I'm just doing it for your purposes, and it has the minus. So what we do in chemistry is the Criss-Cross rule. So you crisscross those charges, and then that's going to give you your ionic formula, okay? So again, let's begin with aluminum oxide, right? So aluminum has 3+, but that 3 is going to cross over to the oxygen. Oxygen has 2-, it's going to cross over to the aluminum, so it's going to be aluminum 2O3, right? Now, for lithium, you have 1, so you're not really going to write the 1 there. when you crisscross over, because again, we don't usually write the 1 in chemistry. Then sulfur has 2, so that's going to go over to lithium. Barium has 2 and chlorine has 1, so barium, the 2 is going to go to the chlorine, and that's going to be Cl2. So again, you crisscross your charges, and that's going to give you your ionic formula. Now, what is binary ionic compound, and what is 1 and 2? So for binary ionic compounds, what you need to know is that you have 2, okay? You have 2 compounds. That's why it's called binary. Why is it ionic? Because again, it's a metal and a non-metal. And why is it compound? Because again, you have 2 things, okay? So when you have type 1, is because you have only 1 charge. If you have type 2, is because you have multiple charges. And usually what happens is because you have a transition metal, okay? I'm not going to go into the naming of this video, but I wanted to show you that it's really simple. So if you, again, let's do a review. For ions, you have 2 types. You have cation and you have anion. Cation is positive because you're losing your electron or electrons. It can be plural. Anion is when you're going to gain an electron or various electrons, and that's going to give you a negatively charged ion because, again, you're gaining that negativity. If you have a metal and a non-metal, usually speaking, that's going to be an ionic bond. Again, is going to be a cation and anion, and that's going to be, again, ionic bond between them. The most famous example is going to be sodium chloride or NaCl or table salt, however you want to call it. And again, it's going to be Na plus because the sodium is losing that electron, chlorine is gaining that electron, which gives it that negative charge. Ionic formulas, just write the thing, write what you have, write your charges, and then crisscross, okay? That's what the pink X is for. It's showing you that you crisscross it. If you have a 1, again, you're not going to write anything because you don't usually write the 1 in chemistry. And for naming, we'll do another video. But for binary ionic compounds, what you need to know is, again, that it is because it has 2 elements in it, okay? It has 2 elements. Now, type 1 is because you have only 1 charge. What do I mean by that? For example, barium. Barium is perfect. You know that barium is 2 plus on the periodic table because it's in group 2. So there's no confusion there. But if I give you iron, on the other hand, you can have iron 2 or you can have iron 3. And usually that confuses students because they're like, okay, why does that change? Think about apples. You can have a green apple or you can have a red apple. I know there's tons of apples, okay, but I'm trying to simplify it for you. So again, to distinguish that in chemistry, again, that's when we go into naming. That's why you have to write, for example, iron 2 and with the Roman numeral, or you have to write iron 3. Why? Because chemists need to distinguish that. They need to know what type, in this example that I gave you, what type of apple do you have? Do you have a green apple or do you have a red apple? So that's why you would write iron 2 versus iron 3, okay? And so that's why it's going to be a type 2 because there's multiple possible charges. Type 1, there's only 1 charge, so there's no confusion whatsoever. If it's going to be in group 1, you know it's going to have 1 plus, right? If it's going to be group 2, it's going to be 2 plus, right? So if you like this explanation, again, it takes time to create these videos, so please follow, like, share, and thanks again for watching.